I want to do a couple of conversions from equations in spherical coordinates to x, y's, and z's, and vice versa. So I'm just grabbing a couple of the even-numbered problems out of the textbook here. So here's one where it says you've got this equation in spherical coordinates, rho squared times the quantity sine squared phi sine squared theta plus cosine squared phi is equal to 9, and we want to convert that to x, y's, and z's. Well, in general, this is pretty tricky. But if we look for certain things, and this one's set up that way. I mean, for instance, if I distribute this through, there's certain things I can see. And the one that jumps out at me first is here. This is the rho squared cos squared phi, right? Because this right here is rho cos phi squared, and rho cos phi is z. So this is z squared. Likewise, here I see the rho sine phi, which was the r, but then times the sine of, and I didn't write this right, this is the sine of theta. That whole thing's squared. So squared. So this is the r times sine theta, that's y. So what I have here is y squared plus z squared equals 9, and that's a cylinder. In fact, I got curious on this, and so I'm going to plot this. Yeah, so I solved for rho and took, so I divided by that stuff, took the square root, and ended up with this thing here, and it looks like the graph looks like this, and sure enough, that's that looks like a cylinder. Parallel to the x-axis, in fact with the x-axis right down the center. I really like the way it ends up looking though. I don't know, it just kind of looks like it's a cylinder that Spider-Man made or something with this with the grid on it here. Anyway, yeah, that's y squared plus z squared equals 9. Cylinder, radius 3, centered around the x-axis. Now let's go back and try converting the other way. So then I find this question where they give me this x squared plus 2x plus y squared plus z squared equals 0. And although I don't need to do this, I look at that and I say, what the heck is that? It's kind of like a sphere. In fact, it is a sphere, because if I complete the square here, x squared plus 2x plus 1 plus y squared plus z squared equals 1. So add 1 to both sides. I've got an x plus 1 squared plus y squared plus z squared equals 1. So I have some idea that that's a sphere of radius 1 centered at -1, 0, 0. So back 1 on the x-axis here, sphere of radius 1. So it just touches the origin there, right? But what they want is for me to put this in spherical coordinates. I say, okay. So going to spherical coordinates, there's one straightforward way that always works, but sometimes it's more work than it's worth. I can, every place I see a z, put in a rho cosine phi. Every place I see an x, I can put a rho sine phi cos theta. And every place I see a y, I can put a rho sine phi sine theta, right? However, there's times when I notice things like x squared plus y squared plus z squared. Well, that's rho squared. So what I have is a rho squared plus 2x, because that one's not there, but x then is rho sine phi cos theta equals 0. So there's the converted equation. You look for as big a piece as you can. If you can recognize the rho squared, then that's probably the quickest way to do things. Otherwise, just you substitute in, and you got to do a lot of trig identities to simplify. I would on this one divide both sides by rho. Whenever I do that, I have to be careful, because if rho equals 0, you've got a solution here. And so my concern is that dividing by rho might remove a part of the graph because I don't have it as part of the equation anymore. But in this case, I can, whoops, divide by row, so that's just a row. If I can see that the origin is still in there, then I haven't got anything. Rho equals 0 is only the origin. I don't care what theta and phi are. If you haven't moved away from the origin, you're at the origin. So dividing by row has the potential of maybe changing the graph by a single point. If this still passes through the origin, then I haven't lost anything. And in fact, this does pass through the origin, and I can see that because by taking either theta equals pi over 2 or phi equals 0, either one of those would make this side equal to 0, and hence rho is equal to 0, and you've got the origin. Okay. I'm curious to take a look at this one to see that it's a sphere where it's supposed to be. So I type into my graphing calculator here what I want, and I see a sphere. And is it on the negative x-axis? Yeah. It's the y-axis running that way, x-axis running this way, so that's on the negative side of it. And there's a sphere. It's interesting to me, seeing the last example and this example, the grid on it is just not the standard grid that you see on the sphere. And sometimes I look at that and I say, it would be fun to play with that grid and see if I can color things in that grid to get sort of a non-standard coloring of the sphere. Yeah, I think that's going to be the topic of another video or maybe an in-class assignment here. But it looks cool with that funky grid. It's like all pinched down right at that point. Anyway, there's a couple of conversions.